Okay, so on to the part three of our LAM costing. Okay, so this is example 5 on LAM costing. So these examples will showcase to you guys on the selection of two different types of LAM. So mainly LAM A, which is the tungsten filament, and then LAM B, which is the fluorescent tube. Okay, so you're given a scenario where you need to illuminate a space for 20 hours a day with illuminance requirements of 18,000 lumen. So this needs to be done for a total period of 2 years, and we need to consider the costing. So in costing, we have your initial costing and your running costing, and then what is the total cost of the system over 2 years. So over 2 years, you need to find out which is more cheaper to install and run. Is it the tungsten filament or is it the tubular fluorescent? Let me check. Okay, I'm recording. Okay, so you'll be given a table where LAM A, you'll be given what is their voltage, their efficiency, what is their lifespan, their installation cost, their luminaires and gear. So luminaire and the gear uh, is the fitting. So you have your light. You actually need a fitting for you to put your light onto it. So this is your installation cost. And then next you have your lamp cost, which means you'll need to change the lighting physically. And this is not this installation cost and the lamp cost is different thing. So lamp is the light itself. The installation, this is the body of the lighting. So sometimes you need to change one or you have to change all. But usually this installation cost will include all the wiring costs as well. And then finally you have your electricity cost. So electricity cost you have to take into account when you are considering the running cost. So with that, you have all your information required to find out what is the total cost of this system over a period of 2 years. So first, let us have a look at the LAM A. So to find out the amount of light or lumen given out by this LAM A, we just need to multiply the voltage with the efficiency. Then you'll be able to get your lumen, which is 1200. And with this amount of lighting given based on this lamp A, you'll be able to find out what is your number of lamp required. So this question, they tell you that this area, this space, requires 18,000 lumen. So lumen can be obtained from the voltage multiplied by the efficiency. So you can take out the W and you'll be left with the lumen. So from there, you just divide it together and you get a number of lamp or lights. So in this case, you'll get about 14 point something. In the case of you getting 14.5 lamps. So whenever you consider the number of lamp required, if it's in decimal places, you want to round it up. So if you round it down in the case of 14.2, that means you're not getting the required amount of lighting needed for this space. So when it comes to calculating this lamp light here, the amount of light required here, if you get a decimal place, always round it up so that when it comes to the amount of light required in that space, you have sufficient or more than the requirement. Because if you round it down, then you will not hit the requirement of the requirement specified for this space. So remember, when you divide it, you get the number of lamp. If it's in decimal place, just round it up. Okay, so next, when you have this number of light, then you need to multiply with the parts and the installation cost. So you just multiply them together, add them, and you have your total installation cost. So this is when you first install the lighting system in your space. So it actually costs this amount of money, which is around 40 ringgit. So next, you want to find out over this period of 2 years, which is 365 days, and this light need to operate for 20 hours a day over 2 years period of time, you'll find out that over this period of time, this light needs to be on for this amount of hours, which is 14,600. And then based on this amount of hour it needs to be on for this area, then you have to divide it by the lifespan. So in this case for lamp A, the lifespan of this light is 1,000, which is mentioned here. So after 1,000 hours, then this light needs to be replaced. So we divide it by the number of hours it requires to be on over the lifespan, and we get a value. So this value here, we also still have to round up if you get it in decimal. So we cannot round it down if it's less, because if you round it down, that means at that situation, during your final period of time or the final time frame of the 2 years, you actually do not have a light if you round it down. So in this case here, always round it up if you have a decimal. Okay, next off is the number of replacement. So we are able to work out that we need to replace the lamp or the light 15 times for the period of 2 years. But we need to minus out the first installation, which we have already taken into account here on the previous part. So here, if you have already done this part, we will need to minus it out by 1 times because we already done here. So over the period of 2 years, excluding the first installation or the first calculation of here we have included, we have to multiply it with the number of light that's available for all areas, and then also the costing, and we will be able to get the value of replacing all the lights over the period of 2 years minus the initial first set of lighting we have installed, and we'll be able to get this value. So this is just the physical cost of replacing the light. So the first part, you have your installation. The second part, you have your replacement. And then the third part is your operation. So to light up this lamp, you need electric. And electric costs money. So still using the total amount of time that this light needs to light up, which is this 14,600, you have to divide the efficiency. So you have 100 watt divided by 1,000. You want to make it into kilowatt because your electricity cost is in kWh. So you need to divide this 100 watt by 1000 to put in this K. So K is just a scientific value lah, or symbol lah, to symbolize 1000 or kilo, or one is 1000 lah. So if it's a M here, then you have to divide it by 60, which is 100,000. So M is 100,000. Okay, just so you know lah. So this is sign. What is it called again? Okay, so this is a SI prefix, meaning in terms of mathematical terms, when we give it a K, it's actually in 1000, and when we give it in M, it's in 1 million, and if it's in G, it's in 1 billion. So this is the case for big number. For small number, there's also a symbol for it. So hopefully you still remember a bit of your maths. But in the case of this subject, when it comes to electricity, you only take into account the SI prefix of this alphabet K, which is 1000. So when it comes to this sort of question, please pay attention to here, which is usually in K, kilo. Just divide the initial watt you have in 1000, and you'll be able to get how much energy used for these lights. So here, after computing it, you get that each of these lamp costs 1460 kilowatts per hour to operate. So what about the rest? So this is just only one. We have 15 number of lamp. So the energy used will have to be multiplied by 15, and then you have to multiply by the rate, which is 0.08. Then you'll be able to obtain that for this period of 2 years, to keep all the number of light required to be on at the required time, which is 20 hours a day, it actually costs this amount of money. Okay, so this electricity cost, adding with the replacement cost, you will get this value. They are the running costs. So over the period of 2 years, you still have to remember of this installation cost that you have done previously. So you add them together, this three part, and you get that the total cost over 2 years is this value. Okay, so for this question, once you have done lamp A, then you have to do lamp B. So you repeat the formula, the steps again, similarly, but with their specific value. And then you end up with, at the end of the day, for lamp B, your running cost is just 430 ringgit, as opposed to close to 2,000 when you're using lamp A. So if you look at it overall, you notice that initially, lamp B costs us higher to install. So lamp A is only 40 ringgit, and lamp B is 65 ringgit. But do notice that the number of lamp required for the space is only 5. So lamp B actually have a higher initial cost as opposed to the first lamp A. So hopefully you still remember lamp A is tungsten filament and lamp B is the fluorescent. Okay, so with that, the initial price or the initial installation cost for lamp B is actually much more expensive than A. But when it comes to replacement, we found that lamp A is actually much more expensive than B in terms of replacement. So here, based on their lifespan over the period of 2 years, they actually needs to be replaced up to 15 times, excluding the first installation. So over the period of years after you are installed, you actually need to replace it 14 times. But as opposed to lamp B, you only need to replace it one time because of its long lifespan. So that's where the difference come about. And then next, you will have your running cost. So because of the lesser number of lamp installed and also the better efficiency, so it only costs 876 kilowatt per hour of electric energy to power up all this, to power up one light. So for all the lights required to be powered up, if you were to compare, the electricity cost is also much lower. So when it comes to here, having your answer like this, and then you have your this total running cost and total cost over the 2 years will be good enough for this question if you have it, if you have your answer scheme like this. Okay, but do pay attention to what the question is asking you. So if the question have additional information or additional tasks in terms of like asking you which system is better or what is your recommendation, do write your comments below this after you have solved the question. So you want to state that after finding out the total cost, this should be the selection due to the overall cost being less than your lamp A. So you want to select a system that costs less and not more. If the question is asking you for recommendation on which system to choose. So when it comes to doing calculation question, please just don't look at it, the example being similar and just apply it straight lah. So there might be some differences between what you're given in the example, and there might be some twists in what you're given in your exam. But it won't be very, very far from your example and your final. So understand your example, do your tutorial, and there shouldn't be any problem lah for your final. Okay, so next you have your luminaires. So this is actually just a fitting lah, light fitting, which holds your lamp. So they have a few functions. So based on our requirement or how they are being manufactured, we can use it to absorb and redirect the luminous flux emitted by the lamp. We can have the positioning the lamp in a space, meaning they are hanging. We can use it for protection for the lamp, and also they can have their control gear. So in some cases, if you want this lighting system to be mobile, they can be motor, where this can rotate or move left and right as required. So usually, this will be depend. This will depends on your required space on how the luminance looks like. So this is just a fitting lah. When it comes to a typical office building, it will usually be a fixed fitting. And then depending on your area, you might want to have a covering over your lamp so that it's not so glaring. Okay, next one. When it comes to lighting design, based on different location, you have different level of illuminance. So this represents the task that we want to do in that particular area. So in such area like a classroom or office, we will require a higher level of illuminance. So this is due to us needing to do work in that area as opposed to a public passageway. So in a public passageway, we are not there to do any detailed work. We are just trying to get by from point A to point B. So what we require is just the enough lighting for us to see where we are going and not to trip over, but not too much because we are not planning to do any detailed of or very fine work there. So this sort of standard is established where the level of illuminance for different area is stated. So depending on which standard we follow, there will be different level of illuminance. So when you come out to work, then based on what is specified, then you just refer to the standard code of practice. So in your classwork, I've actually given out some material. You guys can have a look at it. So which is the, let's see, which is the OSH. So here in this guideline, they actually mention a specific table and a specific amount. So do note that different bodies will have different requirement. So based on them, we should design our work accordingly. So this is from Malaysia for the Department of Occupational Safety and Health. So if you go to the last page of this document, you'll be able to find different type of interior or tasks, and they'll have different lux requirement. So this lux requirement is set by usually a government body . So here is entrance is only 100 lux. If you refer back to here, is close to what is specified in this table. So this table is extracted from this book, which is Hall F and Granola. Okay, so different area, as mentioned, will have different level of required illuminance. So we have another table here, which is specified the level of illuminance. Okay, so next we have lighting design for artificial lighting. So in the case of us needing to find out the number of lighting in an area, so we can use this lumen method to find out what is the number of light that's required in a working plane. So you'll be given this formula. No worries, you don't have to memorize. this will be given in a formula sheet to you guys, but you have to understand what is the meaning behind all this value. So you have your N, which, which represent the number of LAN fitting required, and then you have your E, which is your required lux level, and then you have your A, which is what is the area of your working plane height, and then you have your F, the flux of your LAN, and UF and LLF. So UF is a factor. So this is a utilization factor. And then you have your light loss factor. So this you have to find out from your table where most of the value will be given to you. And then additionally, you need to make use of this formula, which is the room index. So this Lumen method will go hands in hand with this RI when it comes to your example question. So in a Lumen method, based on your spacing, either it is a fluorescent tubing or a filament lamp, you have your maximum spacing, meaning you cannot put your light fitting too far apart. So this will come important later on for the later part of the example. Okay, so let's get on with the example. So we have example 6, which is the lighting design. This is using Lumen method. So you can identify that this is using Lumen method given that they have a room reflectance of 0.5 for ceiling and 0.3 for the wall, and they mention the initial light loss factor. This is 0.7. So based on this few additional info given, you know that you have to use this Lumen method to solve the problem. So you're given an office space of 40 by 12 meter wide and it's a 4 meter height building. But for work purposes, you'll need a 500 lux on the workbench, and they are actually set 1 meter above the floor. So coming back to this room index, you'll notice that to get the value for this, you can make use of this sizing that you have been given in the question. So based on the size of the room and also the height from where the light is from the working plane, you'll be able to obtain a value which is a room index. So you're given all of these value and you'll be able to get the RI. So the room index is where you'll be able to get your utilization factor. It's where you need to input all the information given in this table 6.4 to work out what is your UF, utilization factor, which you need to use here in your Lumen method formula. So for your L light loss factor, this value is just straight away given to you. So first off, for this example 6, you'll need to make use of your room index to find out what is your RI. And then from there, you'll be able to draw a line in this table and work out what is your UF. And from this table, once you get the UF, you'll be able to solve the number of lighting required for this scenario. Okay, so here it mentions you need to use Lumen method of design to calculate the number of lamp required, and then also suggest a suitable layout for the lamp fitting. Okay, so you're given that the lamp is able to emit 500 lux, and then you're given the L is 40 meter by 12 meter, and the light loss factor is 0.7. So you're also given additionally the ceiling is 0.5 and the wall is 0.3 for the reflectance. So based off that, you can find out what is your flux or the intensity of your light by multiplying your these two together, which is your luminous efficiency 80 with the 65. So with the W. So you'll find out what is the output of your lamp. So you'll get 5,200 lumen. Okay, so next you need to use you want to find out what is your room index, which is this formula. So you know that your area is 40 times 12 and your HM based on this slide, which is your HM, how what is the distance between your working plane, which is your workbench, and your lighting based on this scenario. So you are given a workbench which is 1 meter above the floor. And in your scenario, it's mentioned that you're given 4 meter high building, meaning from floor to ceiling is 4 meter. So in total, you have 3 meter of difference between your table and your light. So based on the RI formula, if you work it up, you'll be able to get 3, a value of 3. And then after that, you'll be able to use the Lumen method to solve this question. So to solve this question, you have to make use of your table 6.4. So in your question, it's actually mentioned that this is a tubular fluorescent lamp, and so your selection of your lighting fitting will be this. So you're also given that the DLOR is 50%, which is this, the basic downlight at 50%. And then your RI is the room index is 3. So you draw a line here with your reflectance for your ceiling 0.5 and your wall 0.3. So you draw a line here and you'll be able to get the value for this. You'll be able to get a utilization factor for this case, which is 0.46. So with that, you'll be able to extract it, and your UF is 0.46 from table 6.4. And using the lumen formula, you get that your required illuminance is 500, as mentioned here. The required is 500 lux. So you put it into your formula, and then you multiply by the area divided by the lumen that you obtain from the lighting, which is here. And then you just multiply with your UF you obtain from table 6.4 and 0.7 as given. This is our light loss factor. So you find out that the number after you compute this formula is 143.3. So as before, you cannot have 143.3, you cannot have 0.3 lamp. So what you do here, similar to the case of your previous example, you round up the number of lamp. So even though this is less than 0.5, always round up physical object. You cannot have less. So in this case, as in the same scenario, if you round it down, then you will not meet your requirement, your light requirement. So whenever you have a decimal point, in this case, also round it up. Okay, so this is for your part A. So you are able to find out that you need 144 lamp based on your lumen method. So part B was you are required to suggest a suitable layout for the lamp fitting. So here, you can suggest a 9 by 16 row. So this is not fixed. As long as you are able to fit 144 lamp in an area, then it will be good enough. So it doesn't necessarily have to be fit, but when it comes to suggesting a suitable layout, you need to take into account the spacing. So remember when I mentioned here, this slide, this is where this will come into play. So based on your type of lighting installation, if it's a fluorescent tube, then you will use this formula, which is S max equals to 1.5 times HM. But if it's a filament lamp, then you have to use this formula, which is just multiply by 1 meter of their height. So in our case in example 6, we are using tubular fluorescent lamp. So in this case, we have to multiply by 1.5. So when we multiply it by 1.5, we get the maximum spacing for our light is 4.5 meter. So to provide a layout that is satisfying the number of lamp required and also satisfying the spacing, we can just suggest any number of row or columns of lighting where the spacing is not more than 4.5. So if you can give any arrangement that is not more than 4.5 like this, then you'll be good enough for the answer. So notice that your light, there will always be some spacing between the from away from the wall. It won't be dead center at the wall. So you have your lighting arrangement in here. So here, as suggested, you give 9 rows here and 16 rows here, 16 column here. So in total, you should have 144 total number of required lighting based on the lumen method, which is here. So if you were to find out the spacing in between them, this you have to mark it out lah. You have 4 meter in between for the lightings in a row and 0.75 meter for lightings in a column. So you have your size of your building, and with this value, this spacing, you're actually satisfying the requirement of your layout. So your layout is not the layout provided here is not more than 4.5 meter, which is satisfactory for this question. Okay, so when it comes to this is how you solve the question for this lumen method. So when it comes to selection of lighting, it's not just about costing, but there's actually a lot of factors to be considered. So we can have our light quantity, natural light, color quality, glare, any directional quality, energy use, cost, and physical properties. So when it comes to consideration of what type of lighting, first off, we need to find out what is the nature of the area that we want to install the lighting in. So different area will have different consideration, meaning if we are installing light for a pathway or place just for us to walk past, then you don't have to spend so much time and effort to think of different way or the costing behind this lighting system. But when it comes to a commercial building, meaning we have our shopping mall, then we need to consider our lighting system because we need to install a lot of light in that building. So from there, you need to choose the right number or the right light required. So is it efficient enough? Is it cost efficient? And then we also need to choose on the colors. So when it comes to commercial, the colors is quite standard lah. You have a warm light or a white light, usually a warm light in it. So the choice of color actually has an effect on how bright the lamp is. So, like in the case of reflectance, so we know that in the case of reflectance, we have different ratio or based on the surface. So this is also true in the case of light. So we know that light travels a different color of different spectrum of light travels at different speed. So when it comes to emission of light, when there's a difference in color, then this will actually affect on the quantity of light being emitted. So darker color of lamp will actually not be as bright as the lighter color of lamp. So there's actually a difference between, there's actually an impact of color on the emission of the lamp. So this is just to put it, just so you guys know lah. That's why here it mentions the quality. So different light color will not emit the same level of brightness when you compare it with a lighter color. Okay, so if we have natural lighting, let's say for a small building, definitely we should always try to use natural light. And then when in a case of area as required, then you only want to install as many artificial lighting as required. So this is because installing artificial lighting costs money, and then whenever you operate it, it also costs you money. And then after over a period of time, let's say 1 to 2 years, then you need to replace your light. So this costs money. So that's why whenever possible, when it comes to private properties, as in our house, you always want to try to make use of as much natural lighting as possible. And then next we have your glare. So when it comes to installation of lighting, we do not want to install a light which is very, very bright and it becomes a visual discomfort to us. So this is where we can have different shape and size of light, which is there to shield us away from direct lighting. Okay, so and then finally, after all the consideration is done and you know that you need to install a few lighting at a few point in your house or an area, then you have consideration of physical properties. So based on personal preference, if cost is not a concern, then we can have different shape and size for our lighting. So we can have a very, very fancy shape lamp to light up our room, or we can have a very durable lamp to light up our room. So these are the 8 different factors that we want to consider for the selection of a lighting system. Okay, so let's see. we have natural light source. Okay, so I think we can stop here